This chapter focuses on optimizing in-game performance for vehicle mods using level of detail meshes, which switch detail based on camera distance in Farming Simulator. Everything is prepared in Blender, exported via the i3D exporter, and can be checked in the Giants editor or in the game Farming Simulator. Level of detail, LOD, in-game engines swaps meshes based on an object's distance from the camera. In vehicle mods, high-resolution models look great up close but are unnecessary when the vehicle is in the background, yet the game engine still processes all the details, impacting performance. To maintain playability, lower-resolution models can be used at specific distances, creating different levels of detail. This improves performance but comes with trade-offs. The mod creator must model the vehicle multiple times at different resolutions, and more geometry data means increased hard drive space and longer download times. However, the performance gains typically justify these sacrifices. Creating a LOD mesh is usually quicker than making the original high-resolution model, though the process can vary depending on the starting mesh's topology. It's often helpful to duplicate the high-resolution mesh and use that as the basis for your LOD mesh, as this keeps it in the same place in the vehicle hierarchy. When duplicating, give the LOD mesh a clear suffix, such as _LOD, to indicate its purpose. For example, if you duplicate Evian 450 in your Combine model, name the LOD version Evian 450_LOD. Blender's scene statistics are useful for building LOD meshes too. In the 3D viewport header, expand the overlays rollout and enable the statistics checkbox. This displays statistics on the number of objects, vertices, faces, and more in your scene. Additionally, when in edit mode, the statistics overlay shows values relevant only to your active object. After duplicating and naming your LOD mesh, you can start creating the lower resolution version. This involves removing handcrafted details from your high-resolution model, which can be emotionally challenging if you invested a lot of time in those details. Here are some tips to guide you. Be ruthless in removing anything that doesn't affect the overall silhouette of the part. Remove small detailed pieces like bolts, straps, and brackets, which can significantly reduce your model's vertex count. Update textures to paint in small parts, giving the illusion they're still there. Focus on removing parts at the bottom of the vehicle, as they're rarely visible from a distance. Don't worry about floating parts. If a bracket's removal leaves something floating, it might be fine and unnoticeable from a distance. To manage LODs easily, use merge groups instead of changing the vehicle hierarchy. You should have merge groups for your high-resolution model and now create another for your LOD meshes. Assign LOD meshes to this new merge group using these steps. In the Giants i3D Exporter tab, go to the Attributes section. Click Load Current to clear any leftover data. In the predefined panel, set Physics to Exterior Shape and Non-Physics to Exterior. In the Rendering panel, set Merge Group to 2, or the appropriate group for your LOD meshes. Click Apply Selected. You will need a new bounding volume for your LOD. To set up a bounding volume for your LOD's merge group, do the following. Select the original bounding volume created for your merge group. Duplicate it using Object, Duplicate Objects, and ensure it stays in the same location. Rename the duplicated volume to bounding volume _MG2_LOD in the outliner. Navigate to the Giants i3D Exporter tab in the sidebar within the 3D viewport. Go to the Attributes section and click Load Current to clear any previous data. Expand the rendering panel and select Merge Group 2, or the one that's necessary, next to the bounding volume label. Finally, click Apply Selected at the bottom of the tab to confirm the merge group assignment. Since your LOD meshes are managed by a merge group, integrating them into your vehicle hierarchy involves minimal additional effort. It's optimal to make each LOD mesh a child of its corresponding high-resolution mesh. This approach, as suggested in the Modeling Your LOD Meshes section, begins with duplicating your high-resolution object and then positioning the duplicated mesh as a child of the original. This method ensures that the LOD mesh retains the correct hierarchy and transformation alignment with the high-resolution object, eliminating the need for modifications in your vehicle XML file. However, there is one more adjustment needed. Currently, you have several objects, ideally named with _LOD at the end, grouped within a merge group, but the game engine needs further instructions on when to use these LOD meshes. This step can be easily managed from the merge group route. While typically a mesh object, it can also be an empty used as a transform group. In our example with the Combine, we organized our LODs by creating an empty to function as the transform group holding each merge group root object. This empty allows you to apply LOD settings effectively. You'll be setting LOD settings for the parent empty called Evian 450_LOD, which includes various visual elements, for example the transform group for your LOD merge group roots. Here are the steps to configure it. Go to the Attributes section of the Giants i3D Exporter tab and expand the predefined panel. Set the Physics drop-down menu to default to reset all attributes on your empty. Expand the Rendering panel within the Attributes section. Ensure the following settings are configured. LOD enabled. Child 1 distance, 40, measured in meters. Click on Apply selected located at the bottom of the tab to confirm your changes. Enabling the LOD checkbox on your parent empty signals to the exporter that all its children should switch based on defined distances. This setup allows you to have multiple LODs beyond just 2. Each child of your empty serves as the mesh root for each successive LOD merge group, maintaining order in your LOD hierarchy. First LOD